I have to hand off, first of all, and say the other Colin's talk, he has primed me so well for this talk. I should have been paying you, because some of the things you said, I couldn't agree more. And you said that code review is changing. And so we're going to get to a use case in this talk about how I built a code review. And the fancy title is Async Agents in Production. And failure modes and fixes. What that really translates to is, if you wanted to build your own async agent and your own async workflow, what's going to go wrong? How are you going to solve the problems as you do it? So a little bit of context first. We've actually already had Cursor building their browser. This is supposed to be a GIF, but my PDF doesn't like to play it. But this is Cursor's browser slowly coming into existence. So we talked about this earlier. Cursor set off an autonomous agent to go and build a web browser. Huge coding task. And they've done a bunch of other long coding tasks here. So this involves, as far as they say, this involves them prompting the agent and no follow-up prompts. The agent just runs. Maybe they did follow-up prompt a bit. They don't say that they did. We'll give them the benefit of the doubt. But I know if I was building this, I would probably have follow-up prompted a little bit. But in theory, these run for weeks. We've also got Anthropic. We had the Anthropic example mentioned in one of the earlier talks as well. This is actually the code ripped straight from Anthropic's blog. This is their Claude Code harness. So they built a C compiler, and what they ran was this Python code. So you can see they have a prompt file. This prompt file is explaining what the agent should be building, and they use a git command to pull out the recent commit log. They just continuously call Claude, and that is how they built that. So these are hugely long-running background agent tasks. And here we see from Meta Research. This is model evaluation and threatresearch.org. These guys are great. Here we can see some really interesting graphs. We see on the y-axis here the time it would take a human to complete the task. So this is a slightly scary graph. So GPT-3, we talked about earlier, this was one of the pivot points of AI. GPT-3 was capable of completing a task that would take a human about 10 seconds or something. Anything beyond that, you would need to follow up with the AI, talk to it, converse with it, get it to do more. Now, if we fast forward to today, many of us are software engineers in this room. You know that Claude Opus 4.6, you give it access to your code base, you give it a well-structured prompt, that thing can do hours of work for you, and you don't need to follow up. So the task length that we're comfortable to just let an AI deliver on has increased, and there's no sign that this graph is going to plateau. We can just keep using AI to do longer and longer tasks successfully, which of course, as we spoke about earlier, means the amount of tokens that we generate increases exponentially. So this is Goldman Sachs, some research projecting that by 2030, we will have 24 times as much tokens produced as we do today. So you already think we're using AI a lot today. Goldman Sachs predicts that it's going to increase a lot. And if we look at the breakdown of token production here, we can see that non-agent workloads is the dark blue area. So that doesn't really increase that much. That's you talking to ChatGPT. That's you doing your pair programming with Claude Code. That gets a nice sort of linear increase. But where we really start to see these massive increases is in consumer agents and enterprise agents. I would kind of like to know how many people here have actually built an agent. Okay, that is quite a lot of people. That's good. So your agent probably ran on like an API, like Anthropic API, OpenAI API, and you would run some sort of iterative loop. And we talked about tool calling and stuff earlier. So now I'm going to go into my example of an agent, and we're going to look at how it failed. And hopefully this example is relevant to your agents that you've built as well. Obligatory meme slide that I forgot was coming is if you didn't believe that the tokens that we produce are exploding, you only need to look at Maltbook, which is a complete meme and is ultimately a big waste of tokens, but it is quite cool. It's AI Reddit, and people freaked out over it, but really, it's really just Will Smith here on the right, and we're all up in arms thinking AI is going to secretly plot to take us over, but we've just told it to act like a Redditor, ultimately. Okay, so onto my case study. So Colin over here talked about how review is going to change, and I agree. Most of you are probably already using Copilot to review your code. So my workflow as a software engineer has actually changed a lot to become, I use an agentic text editor. I have many agent threads. I ask the agent what to do. I've got all these different directories and projects, and I'm making the agent change code. I then submit that code. The agent knows how to use Git. It opens a PR for me. GitHub Copilot runs on that PR, does a code review, and I ask my agent to use the GitHub CLI to read that review and update my code. And so I use the review process to agentically iterate my code. But I thought I could do this better, because if I had a coding agent that could do more research for me, then this coding agent could pull up things that the GitHub Copilot might not have pulled, might not have detected, and I could get more research into my context. And so I built this. So this is like a bit of a spoiler, but this is the final result. This is on a live PR. This is our production, one of our production code bases. A lot of our code at Doubleword is open source as well. So if you wanted to look at this Doubleword code bot in action, you could just go to our GitHub. You can see my GitHub is down here. So you can search me on GitHub. You'll see all of the Doubleword contributions I've been doing. And in order to make this agent work, we kind of have like an initial spec here of what we need. So we want this to run on a PR webhook. So this is part of an automated business process. This is a background agent. I don't trigger it. I need this agent to be able to search the web. I want it to do research for me. I need this agent to have an understanding of files. I want it to be able to grep the code base. I want it to have the functions we would expect a coding agent to have. I want it to be able to reason, do an inference loop, explore more files, do more research, and then ultimately submit a code review back. So now let's get into some of the challenges with building an agent like this. First of all, challenge 0. Again, we're software engineers, so we index start at 0. Which model? Which model do we use? So Claude Opus, many of you probably using Claude Code to write code. Phenomenal model, incredibly good at writing code. Then GPT 5.4 is really good. If we wanted to go back to that graph that we had of time for a human to do the task and which models are capable of doing that, I think it's about GPT 5 can do a task that would take about an hour. I would say a code review takes about an hour. So maybe something about GPT-5 level or Claude Sonnet 4.6. And then we've also got some open source models that you can see here making a nice appearance. Kimi K2.6. That's Cursor, by the way. If you didn't know, Cursor runs Kimi 2.6 behind the scenes. So we know anything kind of in this threshold, great model to work with. The next challenge is, how do I give my async agent the tools that it needs to read my code and do all of this stuff? And the open source community has us. The open source community has open code, which is phenomenal. Does anyone know what open code is? It's, a few people. It's written in TypeScript, and I know you're mostly Python and R devs, so you probably don't like it. But it's basically Claude code, but open source. And so that gives us kind of our tool harness. That will give us the right reading our files. That will give us everything. So challenge number 1 is finding the right tools. And if we were doing a more bespoke agent or something more in the growth teams space, we might look for some MCP servers such as HubSpot or something like that to pull in the tooling that our agent needs. Luckily for us, we can kind of get it all for free from HubSpot, from OpenCode here for coding. So that's challenge 1. We've identified the tools that we need. Now that we've got the tools and our model, at least the area of models that we're looking for, we can start to evaluate how is this async agent, this background agent, going to work? So this is a great little diagram I pulled off a blog on LinkedIn, and this outlines the general process of a coding agent. And so just to break this down, pink is an input token, gray is an input token that has repeated between prompts, so it's become cached in the inference layer. And then you can see the fresh pink is new input that has come in. And this tiny little slither of blue that you can see at the top of some of these bars, that's the actual output. And you know, in a coding agent, it doesn't output actually that much. It's spending most of its time just reading your code and reasoning about what to do. And some of these outputs are going to be tool calls to read more files. And each one of these bars is another round of inference, like a turn of the conversation. But this is happening in the background. So the agent requests to read more files. We read those files. We send those files back. It does another round of inference. And you can see how many turns of inference this is going to take. So I would say roughly this is about 30, maybe 40. Interestingly, we see here we have to compact the context a little bit because we've read so many files. We've filled up our LLM's entire context window. So that's why the bar comes down, because we run a whole compaction on the context. And we have a fresh pink bar because none of that context is cached now. It's all freshly compacted. So again, OpenCode gives us the tools that we need and all of this context compaction for free. But if you were building your own async agent from scratch, you might want to model how you expect the inference loops to behave, kind of generate a plot a bit like this, and that will help you define how long it's going to take, what kind of tools you need. Would you need context compaction, etc., etc. We've just heard people talking about cost. And this is where we have to sort of face the reality of this coding bot. This little graph here was vibe coded by our CEO, Miriam. and she loves vibe coding plots. So if you want a vibe coded plot, you could reach out to her on LinkedIn. If you search Miriam Doubleword, you'll find her. She'll happily vibe code you more plots. And this is our roughly 30-step PR review, priced with Claude Sonnet 4.6. And the numbers are very small here, so you can't really read them. But what it says is 30 inference steps, an average of 4,000 input tokens per step. So those are pieces of source code going in, and 800 output tokens per step. So the model generating more tool calls or summarizing its work to us. And what we see is this kind of like somewhat exponential, not quite exponential growth of tokens as our agentic process goes on. So $1.76 per run. Would that be economical for me to run as an automated PR review? I think it's probably fair to say, unless you're flooded with cash and you do not care, that is not economical. So we get to challenge 2, cost. And again, this is a nice plot made by our CEO, Miriam. She does all the best plots. And this is the inference trilemma. So any of you building background agents have probably faced this. This is, you can have low latency and you can have low cost, but you have to sacrifice quality and go to a cheaper model. You could have low cost and high quality, but you sacrifice low latency. That's interesting. How do we get there? And just to complete, we could have low latency and high quality, but obviously we sacrifice cost. So now we're paying a lot. And that's your Anthropic API right there. That's your Claude Code, even your Claude Code $90 per month subscription, you're still getting very reasonably priced tokens. As we said, those prices are probably going up. So we are kind of stuck. So how can we trade off latency to get low cost and high quality? Since this is a background bot, we're quite happy to sacrifice a bit of latency. We don't need real-time responses to our code review as long as they come in a few minutes. So we get to batched inference. There's a lot of data people here today. So have you tried batched inference before? Any batched inference users? One batched inference user. Well done. Thank you. So batched inference, if you don't know, which most of you don't, you basically write a JSON-L file. So it's one line is one block of JSON. Each of those is a request, and you upload that whole file to Anthropic or OpenAI, and they will process it in the background for you. And they usually offer 24-hour completion window, and you pay 50% less for your tokens. So that's pretty good saving. The only problem, though, is that we are doing an agentic loop. So as you might have deduced, we can't upload all of our requests in one big file. We have follow-up steps to our agent, and each step depends on the last. So if we do batch to try and save 50% of our tokens, 50% cost on our tokens, we will end up potentially waiting days, months. And so we get this challenge 3 of scheduling. So we have many tools, we have many tool calls, we have many steps. We can't really wait for little batches of one. It's not going to work. So what can we do? And this is where, as software engineers, we have to get a bit creative, and we can look at ways to solve this problem ourselves. So if we move off of the foundation model provider platforms, we could host our own open source model. As we saw that was artificial analysis, by the way, the graph that I had up earlier of the model intelligence. We can see there's good open source models that are reasonably comparable, about 3 months behind, as Colin said a minute ago. So we know we could maybe host an open source model. We could implement our own sort of queuing and scheduling logic. And if we can get enough requests into this model, we can satisfy its KV cache. Who knows what the KV cache is? Yeah, few people have run their own inference engines here. So if we bundle up tons of requests, we can run that through the model. The models are really, really good at doing loads of requests in parallel. So maybe in an organization that's really large where we've got tons of agent use, we could host our own model, run it like that. Tremendous cost savings. The only problem is that there is a lot of overhead to setting up this infrastructure, and we need a lot of parallel work to efficiently use the model. So this, again, is the DIY path works and it's good, but it's not really good for me just trying to build my one code review bot. I might be doing multiple code reviews a day, but not hundreds in parallel realistically. So we're kind of stuck. We're boxed in. We can pay real-time prices. We can accept impractical latency using batch tiers, or we could coordinate loads of work across internal infrastructure and manage it ourselves. You might be able to work out where this talk is going. We are looking for a platform that could offer us a solution to running background agents effectively. So a platform that would manage the GPUs, the infrastructure, the batching and the scheduling of our requests for us. A platform that would optimize its time to first token. So we're not aiming for real-time responses, but we want it to be faster than batched. We want these tokens to get produced pretty quickly. And a platform that keeps models warm so that if we're doing inference steps in a tool agentic loop, the model that we're depending on won't disappear halfway through. We want the model to be up to for the completion of our entire agentic inference process. And ultimately, our 30-step PR review bot could run start to finish in a few minutes. That's the goal. That's what we want from our async agent here. So let me introduce the Doubleword inference tiers. We have been working tirelessly on this exact problem because we believe this is an area of growth in inference. So real time is what you know, is what we all know and love. We've all used it. We've all spoken to ChatGPT and all of these things many times. That's incredibly low latency and high cost. Then we have batch, which I've introduced earlier, which is bulk upload, big cost reduction, but takes a long time, runs many requests in parallel. Great for data science and things like that. But this async tier is specifically designed to enable background agents in a cost-effective way where we can still get results and run agent loops effectively, but at lower latency than real time. And so let's look at our cost comparison now. So these prices as well, by the way, these are comparable to the industry for open source hosting. So if you look at DeepSeek V4 Pro or Kimi K2.6, for example, this is probably about what Cursor is paying when it's generating tokens, if anyone's using Cursor. So there's real-time price. So compare the real-time price of open source models to Claude Sonnet 4.6, we're already at about 50% cost reduction for the most expensive, largest models. And these prices, by the way, are calculated on the actual input usage of the machine to generate and process tokens. So these prices are not subsidized by VC and prone to flying up. This is, if you do the maths to work out how you should price an open source model on a typical high-class GPU today, you'll get about these numbers. This is just fair pricing. So then batched gives us our 50% cost reduction, but async here is what enables our background agents and gives us a little bit of an extra cost reduction. Now we're looking at these prices, we can see, okay, so if we schedule requests on async inference tiers, we're about 50% or less than 50, 40, 35% already here. These numbers are starting to look practical for running a background agent. If we are willing to sacrifice a bit more quality, we can go all the way down to Quen 3.5, 397 billion parameter model, 18 cents per PR review for a 30-step agentic process. That's 10% of real time. And now any like product owners or business operators in the room, dollar signs are appearing in their eyes because they're thinking, I could afford that. I could actually run a background agent that processed live user data or reviewed my code. I can build entire agentic processes on that pricing. This is great. For the use case that I'm talking about here, our PR review bot, I actually did choose to run it on the cheapest model because I don't want a master intellectual agent to work out what's wrong with my code. I want something that will fan out and do as much good research and build good context for me. And I'm going to take that review and bring it into my Claude Code coding session. So if it generates a review that is not 100% accurate, my Claude Code is probably just going to go, disregard that point, not the most important point, but it will catch some stuff that Copilot won't because it can go off and search and do security analysis of OWASP. It can look at the libraries I'm using, look at the best practice implementations. It can generate tons of information. So I'm running on this price, which enables this thing to actually be economical. So just to go back to these different inference tiers, thank you. We're coming to the end. We have real time, which you know. We have batch, which we've introduced, and some of you would be very interested in batch. We host batch inference as well. OpenAI and Anthropic also have batched inference. So if you want to process loads, millions of database rows, whatever, this is perfect. And we have async, which, as you can see, is better for somewhat time sensitive, like our code review bot. And there's other people as well in the space who are latching on to this async idea. We're not the only ones, but we are actively trying to push the dial forwards in this exact space because we believe this is what everyone is looking for, what we need to enable background agents to be economical. So a recap, context and tooling, we solved by leveraging open source, the open code framework, picking a model. We used artificial analysis to look at intelligence. We saw that we can save a bit of cost and get good outputs with the open source models. Saving cost, avoid real-time inference, look at batched or async. And for scheduling tool loops and running background agents effectively, specifically, we are looking at async inference to enable a background agent to run effectively. So thank you. That was me. This is my LinkedIn and this is my GitHub. I don't have the online slides, but if you would like the slides, just take the LinkedIn here, DM me. I will happily send you the PDF of the slides. Thank you very much.